You know that feeling when you see a picture of someone and you just feel like you know them, even if you've never met? Well, in the last few years, AI has gotten so unbelievably good at creating images of people that, well, the person you're looking at might not just be a stranger. They might not even be real. Today, we're going to pull back the curtain on the AI that makes all this possible, a technology that didn't just tweak the old way of doing things, it completely tore up the rulebook. Okay, take a good look at this face. I mean, really look. The detail in the hair, the light in her eyes, all the little imperfections. It looks totally real, right? But it's not. This entire image was basically dreamt up, pixel by pixel, by an artificial intelligence. This isn't a photo, it's a pure creation. So that's the big question, isn't it? How on earth is this even possible? How can an AI not only invent a person out of thin air, but also give us the control to act like a digital puppet master, tweaking every single little detail? That's the mind-bending breakthrough we're digging into today. To really get why this was such a huge deal, we have to rewind the clock a bit, to the world before 2018. The main tech for this kind of thing was called a Generative Adversarial Network, or a GAN. But here's the thing. Those early GANs were basically black boxes. You could ask for a face and you'd get one, but you had almost zero control over what it looked like. It was kind of like rolling dice and just hoping for the best. And this slide really gets to the heart of the difference. A traditional GAN, it got one single jumbled up instruction right at the start. It's like telling an artist, hey, paint a portrait, and then just walking out of the room. But StyleGAN, the tech we're talking about, it does something completely different. It keeps feeding the AI new instructions with the paper called styles at every single stage of the process, from the really broad strokes all the way down to the tiniest details. So to understand this, you kind of need to get your head around a concept called latent space. Just think of it like a giant map that contains every single possible face the AI knows how to create. And the AI's job is to just pick a point on this map and draw the face that's there. The huge, massive problem with the old GANs was that this map was a total mess. It was all warped and tangled up. The researchers had a name for this core problem: unavoidable entanglement. And what does that mean? Well, it means that if you tried to move across their messy map to change just one thing, say make someone's hair longer, you'd accidentally change their face shape, or maybe their gender, or poof, now they're wearing glasses. All the features were just hopelessly tangled together.
And this visual just nails the problem perfectly. See the image on the right? That's like the old tangled map. See how it's all warped and weird? If you try to move in a straight line on that thing, you're going to get some really unpredictable changes. The image on the left, though, that's the dream. It's a clean, organized, untangled map, where you can move smoothly from one feature to the next. And this is where a team of brilliant researchers from NVIDIA stepped in. They came up with a totally new way to build the generator part of the AI, an idea inspired by style transfer, to finally untangle that map.
Okay, so how'd they do it? Let's walk through their setup. Instead of just shoving a random code, we'll call it Z, straight into the image generator, they did something way smarter. First, they passed that code Z through this new thing called a mapping network. And this network had only one job: take the messy map Z and turn it into a clean, untangled map, which they call W. Then, that clean map W is what gets used to inject those style instructions at every single level of the creation process.
So, the key takeaway here: this intermediate latent space W is the secret sauce. It's the whole magic trick. Because it's disentangled, it gives the AI a clean set of dials and knobs to play with. Now the AI has a map where the direction for more hair is totally separate from the direction for add glasses. They didn't just fix the entanglement problem, they designed it out of existence by building a better map from the start.
And once they solved that core problem, suddenly they could do things that honestly felt like science fiction. They could finally play puppet master with the faces their AI was dreaming up.
This led to their coolest and most visual trick: style mixing. Because the styles are applied at different resolutions or scales, they control totally different parts of the image. The core styles, they handle the big picture stuff, like the person's pose and their overall face shape. The middle styles take care of things like hairstyle and specific facial features. And the fine styles, that's all about the tiny details: color scheme, skin texture, lighting. You could literally take the pose from one person, the hair from a second, and the color palette from a third, and just mash them together seamlessly.
But you know, high-level control is only half the battle. What about true randomness? I'm talking about the exact placement of every single strand of hair, every freckle, every skin pore. How do you make that look natural? And not just, well, computer-generated.
This was their other brilliant idea. They decided to add a little bit of random noise at each stage of the generator. Now, look at these 4 images. They are all generated from the exact same style codes. The person's identity, their pose, the lighting, it's all identical. The only thing that's different is that random noise. And you can see the effect right there. The placement of the individual hairs is totally unique in every single one, just like it would be in real life. You know, before this paper, getting believable randomness was so incredibly hard. Older GANs would often just start creating these repetitive, almost tile-like patterns that were a dead giveaway that you were looking at something fake. By giving the AI a direct source of real randomness at every scale, StyleGAN could finally create that beautiful organic variation that makes an image feel, well, alive. And hey, the results really do speak for themselves. This table shows something called the Freshet Inception Distance, or FID score. All you need to know is that it's a score for realism, and the lower the number, the better. The more a computer has a hard time telling the fake images from real photos. The old baseline model scored a 5.25. The final StyleGAN model, a 4.40. That might not sound like a huge drop, but in this world, that is a massive, quantifiable leap in quality. This wasn't just a cool new technique. It was provably, demonstrably better.
So no, this wasn't just another small, incremental research paper. This thing fundamentally changed the entire game for generative AI. It kicked off what a lot of people now just call the StyleGAN revolution. I mean, the legacy of this work is just huge. This level of control didn't just give us better fake faces, it unlocked a whole new universe of creative tools for artists and designers. All of a sudden, concept artists could spit up endless variations of a character. It laid the direct groundwork for the AI image models that are everywhere today, influencing everything from special effects in movies to how we build virtual worlds. It was a complete paradigm shift.
You know, the authors themselves put it best in their own conclusion, and they were not shy about it. They basically said that the old way of building a GAN generator was, in every single way, inferior to their new style-based design. And you know what? They were absolutely right.
Ultimately, what this research gave us was this incredible new power, the ability to cleanly separate the style of an image from its substance. And that leaves us with a really fascinating and kind of deep question. In a world where we can mix and match identity like a collage with just the push of a button, what does that mean for the future of art, and maybe even for our own sense of self?
This is for entertainment purposes only.